If you're installing something, it's okay, but otherwise, I just don't want you to head to your laptops, all right?
All right. Let me do this. Yeah, and then for now on, we'll do the Hangout channel. We had a brain fart.
A lot of giggling. What's going on?
All right, so let me do this.
And if you have any questions during the time we're talking about this stuff, speak up, okay? Ask a question.
Okay, so here's kind of the scoop. So we kind of started these slides last week, but I'll just rehash them, and I might end up going through them a little bit quicker, just because I already have them spelled out here, as opposed to me typing them while I'm going. But kind of when I think about computer programming, and you know, all of you have been through this programming 1 course, you at least have this rough idea of what programming is in your head. I like to break it down into how human beings solve problems. So I like to think that human beings solve problems in terms of memory, asking questions, and repetition. So kind of the question I'll usually ask in day 1 of class is something along the lines of, you know, how many of you got to class today without bumping into any walls? That type of thing. You get the 1 or 2 smart asses that say, oh yeah, I bumped into a wall. But generally speaking, you know, human beings are so good at solving problems that as you're walking down the hall, it wasn't even worth your full attention. You were sitting there with your phone out, texting, or whatever it is, while you were bobbing and weaving in and out of people, and magically, you know, came to your classroom without, you know, killing yourself or falling over or any of this other stuff. And I like to think that we solve these problems generically in terms of using our memory, asking a lot of questions, and repetition. So if you kind of break that problem down as you're walking down the hall, well, you're trying to remember where you're going, and then you're constantly asking these questions, even though you're not necessarily aware of it. You're constantly saying, am I going to fall down? Am I going to fall down? Am I going to fall over? Am I going to bump into somebody? Am I going to bump into somebody? Do I need to turn left? Do I need to turn right? You're constantly kind of assessing the world that's around you and then making little updates, you know, to how you're shifting your weight and stuff like that as you're going. Now, the reality is that none of us are really aware that we're asking all these questions. We're not aware of the various levels of repetition we're doing in terms of walking, putting 1 foot in front of the other, and all the other little micro problems we're solving. And part of that is because human beings are so good at solving problems that we have trouble articulating how we solve problems. And that is the challenge we run into with becoming a computer programmer. So, you know, what's the job of computer programming? At the end of the day, this is to tell a computer what to do. Okay? No more, no less. All right, so if we're bossing other human beings around, you know, that's how human beings interact with each other, and we're pretty good at talking to humans. But now when we're talking to a computer, this is like this alien being that doesn't think like we do. It can't read between the lines like a human being can. So a computer really requires that we break problems down into little tiny steps so that we can give it all those micro steps that it needs to solve those problems. Now, the good thing for us is that the types of problems we solve on our computers are very different than the types of problems we solve in real life. They're significantly more trivial. All right, so you know, even you take your favorite video game, something that seems really complex, Battlefield or Call of Duty, something like that with lots of explosions. You know, games like that, while we might perceive that these are really, really complex and very difficult to write and stuff like that, are actually trivial problems to solve compared to what it took for you to just walk to your classroom today. All right, so one of the jobs we have as a computer programmer is to ultimately tell a computer what to do, and that skill set is what's difficult for human beings to achieve that. All right, so, you know, then the next thing is, what tool do we use? So we like to use programming languages in general to tell a computer what to do. Now, the quality of that programming language, so think about the programming language as kind of like a tool. Okay, this is the power drill that we picked up at the store that allows us to tell a computer what to do. So the programming language is a tool that allows us to solve problems as similarly as possible to how we already solve problems in real life. All right, so if we were, you know, like I mentioned, we're talking to this computer, think of a computer kind of like an alien. So if we're talking to this alien computer that doesn't think the way we think, we have a couple of options where we can drop all the way down to the computer's level and talk to it at machine level, talk to it in binary, zeros and ones, things like that. Not really our style. Human beings aren't going to be very skilled at that. You know, maybe the human version of fairness would say that maybe we drop halfway there and ask the computer to come halfway up to us. And so we kind of compromise, and the computer acts a little bit more human, we act a little bit more like a computer, and everybody's happy. Well, problem is the computer's not capable of doing that, and even if it was, human beings are pretty rigid, and we kind of like our way of doing things, and it's our way or the highway. All right, so this is where this idea of a computer programming language comes in, where it's trying to meet human beings as close to where they started, as close to the way we already solve problems, and then it does the magical translation down to that zeros and ones level that a computer knows how to deal with. All right, so I want us to think about our programming languages as these power tools. And an idea I like to throw around is this idea that which programming language we use doesn't matter. So in your coding 1 class, I think you guys use JavaScript, right? So you learned the JavaScript programming language, and we'll put that in context here in a few minutes. And now in this course, you're doing some iOS development, and you're going to be looking at a programming language called Swift. The punchline is both of these languages are effectively the same. They're both based on a much older language called C, and what we're really trying to get at in this course is this idea that computer programming is a skill set. It has nothing to do with what language we're wielding. Okay? If you were an expert swordsman, it doesn't really matter if you have a broadsword or a short sword. Okay? You're going to look pretty impressive with both. Okay? So something like that. All right? So that's the job of our programming languages. Right, so here's our problem as a human being. As I already mentioned, we're so good at solving problems that we find it difficult to articulate how we solve them. Right, we can't drop down to that level. It's just, we're not used to thinking that way. We're used to ignoring all these details that are really, really complex, but those problems are so passive for us. We've been walking down the hall for so long that it's not even worth our full attention. All right, so that's a weakness that human beings have when we're talking to computers, even using this power tool that's our programming languages. All right, so this next slide is this idea of the mapping. So I like to say that 100% of all programming languages provide facilities for those 3 things we introduced before. This is how human beings solve problems. That's why I generalized it in terms of these 3 things: memory, asking questions, and repetition. Right, so 100% of programming languages are going to give us a facility for emulating memory. Usually this is through something called variables. So you learned about variables in JavaScript. As you start to go through the stuff with Swift, you're going to be learning the Swift way of handling variables. They're very similar. Swift has a couple of little weird things it does with these things called optionals that you'll start looking at. But regardless, it's a way of keeping a piece of information in a named storage container. That's a variable. So every language will have facilities for that. It'll have facilities for asking questions through conditionals. These are usually called if statements, but it's just how do we ask a question in this language. And then we have facilities for doing repetition, whether it's through loops or to a lesser degree functions. Okay, so that's kind of our punchline with this mapping. So a programming language attempts to solve that problem. Solve the problems the way human beings already solve them by looking at how we solve problems and providing a mapping for each of those. All right, that's the world we kind of live in here. So now, the next thing I like to kind of, demystify is this idea of what's a programming language and what's not. So remember, this slide right here indicates the idea that every single programming language will have facilities for these 3 things. So here are some things that are not programming languages. So HTML, CSS, XML, JSON, these are all what I call data representation languages. Their job is to hold information in a structured way so that we can pass it between 2 points. So for instance, HTML is a data representation language that holds information that we ultimately want to display on a web page. All right? And who knows how to interpret HTML? A web browser knows how to interpret HTML. So that doesn't mean HTML is useless. It just means it's not a programming language. We're not using HTML to remember things, to ask questions, to do repetition. It's not built to do that. All HTML does is it formats data. Okay? So kind of something that often gets thrown around that, I'll ask somebody, what programming languages have you messed with? And HTML almost always is at the top of that list. So from your guys' perspective, the only programming language I'm aware of that you've messed with is JavaScript. Okay, now have any of you, what other languages have we been exposed to? I know you're starting Swift now, but just is a general rule, have you guys been exposed to anything other than JavaScript and now Swift?
Java, or you're saying Java or JavaScript? JavaScript. Okay. Yeah, it seems like everyone is.
Okay,
I
so
don't think anyone else.
all right, so everyone basically has a semester of JavaScript-ish, and then a 15 minutes of Swift, somewhere in that ballpark. Okay.
Guys, Swift is what we're using now. Swift is the language within Xcode.
Oh, so was I being too generous when I said 15 minutes?
Yeah. Yeah, I mean, well, a couple of the guys just added at the end of last week. So
Sure.
I actually have a couple of them downloading Xcode right now. So Swift
I get it. All right, so that's going to be the language we're moving into. But like I said a few minutes ago, they're all the same. All right. In fact, Swift. So this next slide, I kind of look at the evolution of these languages. So I've kind of thrown these things on two sides. These are our web languages over here. These are our native languages. So native languages tend to have a focus on performance, where our web languages have a focus on convenience. But at the end of the day, from us, when we're thinking about computer programming as a skill set, we can just think of all of these as being the same. All right, these are all computer programming languages. They all will have facilities for these three things. You know, each of these languages might have little idiosyncrasies that make it better, or make them lend themselves to solving certain problems better than another language might, but they all solve kind of the same stuff. These are programming languages. All right. So for you guys, the reason I kind of draw this chart this way, notice at the very top we have this language called C, and I'll actually color code this guy. So there's our language C. Every single one of these languages came from C. Okay, so C was not our first programming language, but I think by modern programming standards, it's fair to say that C is our first programming language that matters to the modern developer. So, for example, if you were a C programmer, if you wrote C code years and years and years ago, not that it doesn't still exist today, but it's much rarer today, all of these languages already are going to look fairly familiar to you. Okay, and they're going to look familiar to you because they all took a cue from C. Now, for you guys, you've seen JavaScript. So JavaScript is very, very, very based on C. So it really kind of came into this little zone right here between C and C++. So JavaScript effectively uses C syntax. All right, and you're going to see down here, Swift has a whole lot of stuff in common with JavaScript, and we'll kind of talk about that lineage here as we kind of walk through this. All right, but understanding is once you know one of these languages learning any of these other ones is going to be relatively trivial, because now you've captured computer programming as a skill set, rather than, oh, I'm a Java programmer, but C# doesn't make any sense to me. Especially, that would be maybe the most ridiculous statement to say on this entire screen, because these languages are literally almost identical, all right, between those two. But in any case, this is kind of the languages we're going to explore. And what we did last time is we talked about this side of the world for a little bit, even though ultimately what we're going to be doing in this class is on this side of the world. All right? So I like to kind of get this out of the way, but we really want to understand the world of software development today, and that's where this comes from. All right, so we're going to be talking about the web side of things here for a few minutes. So in the web world, we have, this really follows something called the client-server model. So we have a client talking to a server. All right, so the example I usually use to start off with is forget about technology and just think about McDonald's. Okay, so you're a McDonald's client and you're going to go in and talk to the McDonald's server. So you go in and you ask for a Big Mac, and the person behind the counter magically gives you a Big Mac. They put together the solution to what you asked for and they hand you a Big Mac. Okay? So that's real-life client-server model. Well, now we're going to take this down to the web world, where our web client is a web browser, so Firefox, Chrome, whatever, and then our web server is one of many different things. Okay? But at the end of the day, because we're experiencing web applications always through a web browser that understands HTML, CSS, and JavaScript, no matter what this web server is doing, no matter what technology is being used over here, the output of that program will always be in this format: HTML, CSS, and JavaScript, because that's what this dude understands. All right? So the idea here is that who's digesting the information from a web browser? The end user. We are. We're sitting in front of our web browser. We look at the pretty pictures and text. That's our experience. So the web browser, this is called client-side development or front-end development. So both of these are synonyms. Okay, so when you're a developer that's primarily working in this environment and your audience is the end user who's actually using the web browser, that's a client-side or a front-end developer. Now, over here, this is the server side. So if you're writing software over on this side, where your main audience is a web browser, that means no matter what programming language you use, no matter what technology you're using over here, that program always outputs stuff in this format, because that's what this guy understands. Okay? So this would be the client-server world of web programming. All right, so what I mentioned last time, we looked at a couple of different languages. So these are all server-side languages that we're initially talking about. So our client-side languages are always going to be HTML, CSS, and JavaScript. And as we mentioned before, HTML and CSS are not programming languages. Those are data representation languages. So the whole reason we have JavaScript, the whole reason this guy exists on the client side, is because HTML and CSS can't do programming stuff themselves. They don't have a way of remembering things. They don't have a way of asking questions. They don't have a way of doing repetition. So if we need to do any dynamic stuff like that inside the web browser, we rely on JavaScript as our programming language, because all web browsers have a built-in JavaScript interpreter. They understand that programming language. So we would do things like form validation. When somebody puts a username and password into the Amazon website for logging in, well, before we actually send that request over here to the server, maybe we have JavaScript checked to make sure you filled in both boxes before we waste the server's time trying to authenticate somebody that didn't put in all the information. All right, so that would be an example of where we might use JavaScript here on the client side. All right, but now what we're going to talk about here is the server-side technologies. So what are some various things we can do over here on the server side? Well, we can use a language like PHP. We can use a language like Ruby. We can use a language like Python. We can use a language, I'm just going to write it as Node.js. This is kind of our current cool kid. All right? And I like to compare these guys because, like I said before, it doesn't matter which of these programming languages you're choosing to leverage over here on the server side. Every single one of them will ultimately spit out output that looks like that. Okay, because that's what his audience understands. That make sense? All right, so now that's a little different than what we're going to be dealing with here in the iPhone world. Okay, on the iPhone world, if we're going to end up talking to a server, so for instance, you guys will do some stuff where you're like bringing in images from Instagram and stuff like that. Okay, when you ask for an image from Instagram, you're not expecting it to come in HTML format because your iPhone is not a web browser. You don't require it to be in this format. You just need it in some sort of format that you can digest and work with inside of your web browser. So just like in real life, if somebody were delivering you a letter, if somebody was delivering you a letter, sorry, I got a weird pop-up on my screen that said something about a wireless network being compromised or something. Okay, if somebody were to deliver you a letter, they could certainly write that letter in HTML and CSS if they wanted to, right? And a human being could look at it and say, okay, well, this looks a little bit weird, but I pretty much get what this is saying. But realistically, if somebody wrote you a letter, they would probably choose English instead of HTML and CSS because you're kind of used to using English, and that's a more effective way of communicating with you. Okay, same thing's going to be true in our iPhone world, where if we're talking to a third-party server somewhere, we're asking for images from Instagram, it's going to send those images to us in a potentially different format because it's more convenient for us to work with that format on an iPhone. But the punchline still is we have a client in that world, which would be the iPhone, and we have a server, which is whoever we're talking to, in that case, Instagram. Okay? But in the web side of things, I like to look at these 4 technologies. They really represent the history of our server-side technologies. Now, that isn't to say that these are all of them, because we certainly have the .NET languages like ASP.NET that we can throw in there. We have a bunch of different Java languages, Java Servlets, JSP. So we have more things we can put in this list, but I like to look at it in terms of these. All right, so we have these guys as possible programming languages we can use here on the back end. Now, at some point in time, though, we're going to need a server that's going to leverage these languages for us. Now, historically, when we think about a web server, kind of our go-to enterprise-level web server would be something called Apache. All right, so let's call it 50% of the entire internet is using Apache as the web server. Realistically speaking, the other 50% is probably IIS, which is Microsoft's Internet Information Server. All right, but let's just say, for the sake of our argument, that Apache is the only web server that's out there. All right, so Apache's been around, let's just say, since the beginning of the internet, so for 25 years or so. And if we're going to use a language like PHP, and kind of notice here where PHP fits in our evolutionary scale. So before PHP, with this language called Perl. So Perl was existed before the internet existed. Then PHP came out as a response to, oh, people need to write server-side stuff for the internet, so why don't we create a language specifically designed for the internet? Great, whatever that means. Okay, so we're going to say PHP was our first language specifically designed for the internet. But PHP required a web server to run it. So what we would use is we would have Apache being the web server, which would then have the PHP module installed on it, and that PHP module knew how to take requests for PHP documents, run it through this module, which would then run that program, and ultimately output HTML, CSS, and JavaScript. All right, so this is all fine and dandy, no harm, no foul, just like our most modern languages. It's still spitting out HTML, CSS, and JavaScript. Now, the problem, though, with PHP, if we're kind of looking for weaknesses and why we came up with some of these other options, is PHP required an IT skill set. That is, we had to get a web server installed somewhere, so we had to get Apache installed somewhere. We had to configure it to know how to work with PHP. We ultimately had to get it somewhere out there on the real internet so that other people that aren't on our laptop can see our page. So there was a lot of extra stuff that has to happen before we could even start writing software using something like PHP. So it required this IT skill set. It also did not support something called MVC. So let me kind of pause this slide here for a second. Let's talk about what MVC is. Now, one thing I'm a big advocate of, and the reason why I'm kind of talking about all these different technologies and trying to put them in context, is we have all of these buzzwords out there on the internet. Okay, so you can go on to Reddit or something like that and look at one of the tech blogs, and you see them talking about 50 or 60 different technologies, some of which you've heard of, most of which you have no idea what they actually do. Okay, there's all sorts of just buzzwords floating around out there. And I like to demystify these things, because if you take all those buzzwords, ultimately they all fall into like one of 5 categories. They're solving one of 5 different kinds of problems. And if we can gain an appreciation for that, then as a software developer, when we are solving a problem, we then pick the right tool for the job out of our list of tools for solving a certain kind of problem. All right, so there's this phrase called design patterns. Have any of you guys ever heard this before? It's less of a buzzwordy thing and more of a, if you've ever talked to a software engineer who's trying to act smart, they might toss this word around like they know what they're talking about. Okay, any of you ever heard of this phrase, design patterns?
No.
No? Okay, so if you were ever in a job interview for a software developer position, they might toss this phrase around and trying to almost sound like they're smarter than you or something like this. Design patterns are just an idea. So what this is it's a proposed good solution to a, quote, common problem. All right, so that's what a design pattern is. Proposed good solution to a common problem. So the idea here is that we deal with design patterns all the time. A good example would be eating a banana. All right, so there's kind of two approaches to eating a banana. You have the generalistic human approach, and then you have the way a monkey eats a banana. All right, so what do humans usually do when they're eating a banana? They usually take the stem and they break it off there, right? And then peel it down. That's the human approach. You know how monkeys eat bananas?
They go from the bottom.
Yeah, they go from the other side. So they flip a banana. Go ahead.
Someone said that Brandon said they eat them from the bottom.
Yeah, I heard him say it, so I'm responding to that. Yeah, so they eat them from the bottom. So they flip the banana upside down, they pinch the bottom of it, and then they can just pull the banana apart. It's actually significantly more efficient to the way human beings eat bananas. All right? So the typical human being approach to how to eat a banana, we would call that the human banana eating design pattern. We can say that's a proposed good solution to the problem, but really monkeys have us beat. All right? They have a superior design pattern for eating bananas. Okay? So, but both of these are just ideas. They both ultimately will allow us to accomplish eating a banana. All right? So, a design pattern is just a proposed solution to a common problem, and in that case, we're saying that eating bananas is considered a common problem. But notice I put a couple of these things in quotes. So, for example, when I say good solution, as we just discussed, we have two reasonable solutions to eating a banana. Which one is better than the other? I guess it's in the eye of the beholder. Are they both good solutions? Sure. Let's say they're both good solutions. But what does that really mean? So this is kind of a gray area. Similarly, what's a common problem? You know, if I'm an engineer who works for Lockheed Martin and doing weapon systems or something, maybe a common problem for me is fuel consumption of a rocket. Well, most of us don't care about fuel consumption of rockets. So design patterns having to do with fuel consumption of rockets are going to be a little bit off our radar. So the punchline here is that there are literally an infinite number of design patterns out there. So when somebody asks you what's your favorite design pattern or something, which seems like a ridiculous question, but they ask that on job interviews, it's really a stupid question because there's an infinite number of them. Now, having said that, as it relates specifically to the software development world, we have all sorts of proposed good solutions for various problems that we run into in software development. And every now and then, one of them kind of bubbles to the surface as being, kind of people accept it as a standard. Okay? And one of these is this idea of the, so here I'm going to write a couple of these guys here. So the three design patterns I like to talk about is MVC, Singleton, and Observer. So first of all, one of the requirements for a design pattern is it has to have a funky name. Okay, if it doesn't have a funky name, they don't accept it in the design pattern community. All right, so first one we'll talk about here, which is related to this previous slide, is that PHP did not support this thing called MVC. So MVC, this guy stands for Model View Controller. Okay, well, whatever the heck that means. At the end of the day, this is what MVC says. MVC says it's a good idea to keep our interface design and our programming logic in two different places. That's it. That's all MVC says. Keep them in two separate places. Make your, the part of your application that makes things look pretty in one place, and the part of the application that makes things function in another place. And then we'll have some way of making those two things communicate with each other. All right, so when we say that PHP did not natively support MVC, what we're really saying is in the early days of PHP, when we were writing web applications, you had one document that had your interface, your HTML stuff in it, as well as your PHP code in it, okay, inside the same file. Now, in the early days of the web, the websites we were building were fairly, trivial websites. Also, fine. So this wasn't that big of a problem back then. Well, as our computers got faster and as our internet connections got faster and the types of problems we were solving on for web became more and more complex, all of a sudden that file that had HTML and PHP in it started becoming started becoming larger, more complex, more unwieldy, harder to maintain. So now it starts making sense to, well, let's kind of pull those two pieces apart. So that we can work with those things. Now, having said that, both have been solved since. All right, but we got to look at this through the evolution of these languages. PHP is still very much around today, but it did start showing weaknesses, and before these things had been solved, we needed a new, kind of an upgrade, something that solved some of those problems, and this is where Ruby comes in. Now, you never hear somebody just call it Ruby. They always call it Ruby on Rails. All right? Have we heard of that before? Ruby on Rails? Do we have any yeses?
Tyler was saying heard of Ruby, but not Ruby on Rails. Is that what you said? Yes.
Oh, that's not possible.
Yeah.
All right, so in any case, typically you would nobody writes code in Ruby. Okay, nobody writes just code in Ruby. It would always be in the context of Rails. And I'm going to rewrite several of these guys here. I'm going to say PHP on Apache. I'm going to say Ruby on Rails. I'm going to say Python on Flask. Oh, and by the way, what time are we done today? 55?
Yes.
Right?
I know. We're good till 3.
Good through 3. Perfect. Okay. So we have Python on Flask and then Node.js. I'm going to rewrite this guy, and we're going to say this is JavaScript on Node. All right, so for each of these, here's the programming language, here's the web server. Here's the programming language, here's the web server. Here's the programming language, here's the web server, so on and so forth. Okay? So what did Ruby on Rails bring to the table? Well, it had a built-in web server, so now we didn't have to do that IT solution. Now you can sit down and start writing your web application right off the bat, and you only needed to think about that IT problem when you finally were done with your project and needed to find a home for it somewhere out there on the internet so other people could access it. But in terms of sitting down and just starting to write software, Ruby on Rails lets you do that because Rails came with Ruby. Okay? Similarly, Ruby on Rails had built-in MVC. So we're going to say this had a built-in web server and MVC. All right, so they did this through something called a template engine. So you would put your HTML in a single document, and then you'd have your Ruby code in another document, and then you would be able to inject the value of certain variables into your HTML templates. So you would have just a plain Jane HTML file, and somewhere at the top it might say current logged in username is equal to some variable placeholder, and then your Ruby code can then inject the current logged in username into that placeholder. So this fixed a couple of those problems that existed in PHP. This guy also brought to the table a management library called Gems. Okay, so Gems made it easy to bring in third-party libraries, plugins, into the Ruby development experience. So again, from a developer's perspective, we don't have to spend a whole lot of time going and grabbing other plugins that we're going to use in our application, configuring them, making them all work with Ruby, seeing what's broken, seeing what's not broken. We can just install anything that's in the Gems library and have it instantly just work. So again, it's all about rapidly being able to create these applications. Now the downside with Ruby is this required us to do things the Ruby way and had a very specific directory structure. All right, so the idea here is that While Ruby did a whole bunch of this stuff for you, they also kind of locked you into doing everything their way, which was great in its time because there weren't other ways to accomplish these things. But since then, now we have, for example, I talked about this idea of how MVC is solved through something called a template engine, which is also how PHP has been saved. So MVC is now supported in PHP through various third-party template engines. Same thing that Ruby has built into it. Well, the thing that was built into Ruby day one may not be as good, or might not have some features that have evolved over the years. Well, if you want to do MVC with Ruby, you have to use Ruby's built-in way of doing it. Okay? So this was a weakness of Ruby, as they solved, a huge percentage of the problem for you, and you were stuck doing it their way. So on one hand, building web applications with Ruby is really, really, really fast because everything just works and you don't have to do very much configuration. On the other hand, your hands are a little bit tied to having to do things a certain way. So now you have kind of the next guy on the list, this Python on Flask, the programming language being Python, Flask being the server. How many of you have heard of the programming language Python? Okay, heard of Python. All right, so Python was actually made famous by Google. So Google kind of adopted Python early on as one of their major languages. And the big argument here is, we might say, well, why did Google choose Python? Is it because Python's some sort of amazing language? Well, I think generally speaking, people tend to be happy with Python. They think it's pretty good, but the biggest reason why they adopted Python as an internal language is, the biggest thing Python has going for it is the idea that it was not made by Microsoft. All right, so Google does not want to have a reliance on their competition. All right, so they want to use internal languages that are not made by Microsoft and are not made by Apple, for example. Okay, so Python became one of their kind of core languages at Google. So on one hand, we might say, well, why did Python on Flask really come out? So Flask is a third-party web server. So this doesn't come with Python. Instead, we can choose to download this and have it work seamlessly with Python. But those two technologies are separate technologies. So on one hand, why does this whole thing exist? Well, it exists because the Python programmers were crying and saying, why can't we do what the Ruby guys are doing? All right, we want to be able to deliver web applications as well. All right, so that's that side of things. Now, the other side of things is, like we talked about up here, there are some weaknesses with Ruby on Rails. Okay, there are some problems with that maybe could be solved in the future, and Python we can just say, did everything Ruby on Rails did, but allowed us to make choices about what tech we used. And Python specifically has a package manager called pip, which is kind of like gems. Okay, that allows us to bring in third-party stuff. All right, so generally speaking, we can say Python did that. Now, the other thing Python brought to the table is the idea of support for something called RESTful APIs. All right, so that's probably, have you, in terms of buzzwords, have we heard of this, the idea of a RESTful API or a REST API before? Is that a word you've seen at some point? No worry. Okay, that's fine. So this falls into the category of these other buzzwords. So I'm going to actually just start a slide for this. So I want to finish this conversation first. So, we're going to talk about APIs next time. So these are application programming interfaces. And at the end of the day for us, this has to do with what if we want to bring in, so earlier I mentioned like Instagram. What if we have an iPhone application and we want to bring in content from Instagram into our iPhone application? All right? So we're going to have some mechanism for our iPhone app to talk to Instagram. Okay? Instagram's not made by Apple, right? So these are two separate companies, two separate solutions, and we need to have a way for these guys to talk to each other if you want to bring in Instagram data into your iPhone app. And that's accomplished through something called an API. All right? So Instagram exposes some of its features, some of its data to things like iPhones, like Android apps, like websites, through its API. Now, APIs historically came in a lot of different flavors. In the early days, they were proprietary. So in order to talk to Instagram, for example, you would have to have some internal knowledge about how Instagram's API specifically worked in order to make your iPhone talk the right lingo to Instagram. So, maybe Instagram spoke German, for example. So if you walk into a shop and you don't know what language they're speaking, you're going to kind of wait for them to start babbling and then hope you know that protocol, hope you know that language, right? And if they start speaking German or Chinese or something and that's not in your wheelhouse, well, you're going to have some trouble. You're going to have some trouble talking to them. Same thing is true here. So the idea of a RESTful API provide a standard way to talk to third-party data sources. All right. So at some point we'll talk about what that standard way is, but that's the idea of a RESTful API. Okay, it's kind of our modern cool kid standard for how we talk to third-party data sources. All right.
Hey, Mike.
Yep.
Before we wrap up, I just so can we get everyone on that Slack channel?
Sure. Do I have everybody's email address?
I put them in. I put it in Slack. I put a message up yesterday.
Oh, did you? Okay.
It just says, "Can you add?"
Okay. Yeah. As soon as we're done here, I'll add everybody to that.
Yeah. And do they? So they'll just be like when you send an invite, they'll be able to just go in and create an account, right? They don't have to create an account before it.
Correct. Yeah. That'll take them through the whole process.
Okay.
They won't have to do anything.